Hey, Austin. Hi, Coach Hughes here. It is 11:05 at night, and I am recording another video notes because I'm the bomb. Today is going to be on page 10. It's Domain and Range, Part 1. Part 1 will discuss continuous graphs and data. Continuous graphs and data. So we talked about continuous versus discrete in our last block. Now we're going to focus on continuous. We're going to look at graphs and data. So we're going to use the same state teak, A to A. It says determine the domain and range of a linear function in mathematical problems. Determine reasonable domain and range values for real world situations, both continuous and discrete, and represent domain and range using inequalities. We're doing all of the things today. I want to introduce our topic in a real world problem context. So you can see there's a connection between math and how it applies to you in the real world. Okay, so we're familiar with Uber or Lyft. This is when driving for Uber, there's a base fare, which is a flat fee that you're charged at the beginning of the ride. Suppose the base fee is just $2 and you are charged 40 cents per mile driven. The amount charged is a function of the total of miles driven. So this is how you are going to pay your bill at the end of the night. This is telling you this is a function. Find the domain and the range for up to 20 miles. Okay, right now you have no idea what the word domain and range even mean. Ugh. Let's talk about it. So it does want us to go over again an independent variable and a dependent variable. And we learned that last block, okay? Remember, independent was our X value and dependent was our Y. And here it is, the amount charged is a function of total miles driven. So this says Y is a function of X. Y is always a function of X. Okay, X is what we control. It's our independent variable. We control the number of miles we gotta go. So we control the miles. We don't control the amount that's charged. The Uber company controls that. And since we know how many miles we're gonna go, Uber will charge us based on the number of miles. So the dependent variable is the amount charged. You won't, C-H-A-R-G-E-D, you will not know how much money you owe Uber till the end of the drive. That's why miles comes first. It's independent. So the equation that we want to make is going to say the amount charged, Y equals, how will we be charged on our drive in this Uber? Well, first we're going to have to pay that base fee, which is $2 plus 40 cents per mile. And mile is X. So miles driven equals X, amount charged equals Y. So those are the words associated with independent and dependent variables. Okay, so now that we have our equation, let's think about this logically. What is the least number of miles that we could drive in real life? We could say, hey, I need an Uber. The Uber gets there and you're like, just kidding, my mom's coming to pick me up. So in theory, we could drive 0 miles. Okay. What's the most we can drive? Find the domain and range for up to 20 miles. So it wants us to go up to 20 miles. So 20 miles. So we could do 0 miles all the way up to 20 miles. What's the least amount of money that could be charged? Well, think about it. The amount charged is $2 plus 40 cents per mile. If we go 0 miles, that would equal $2 plus 0, and that would equal $2. So therefore, y equals $2, and the amount charged represents the letter y. So y equals $2. And what that means is you could call for an Uber and they arrive and then you cancel it. They're still charging you $2 for picking up your call and driving to where you are. They don't know that you changed your mind and your mom's coming to pick you up. And now let's do the most miles for 20. How much money would 20 cost? So let's take out the 0 and make it 20. So 0.40 cents times 20. 0.40 cents times 20 miles is $8. Not a bad deal. So now that makes $8, and $8 plus $2 is a total of $10. Now write the X values as domain. Okay, this is the first time I'm telling you what domain stands for. I'm telling you that the domain represents the X values. So since miles is measurable, I can drive in my Uber 1.6 miles. I can drive 2.7 miles. I can drive 18.5 miles. Then that is why this is continuous, because continuous is smooth and connected curves. And here is how you write your domain for miles. We can drive at the smallest amount 0 miles and at the largest amount 20 miles. So your miles that you go could be greater than or equal to 0. I'm reading this backwards. That's a less than or equal to sign, but I'm reading it backwards. So X is greater than or equal to 0 and less than or equal to 20. I'm reading that one forward. X is less than or equal to 20. I'm reading that forward. Okay, and this is how you would write a continuous domain. It starts at 0, ends at 20 miles. Now for the range, our smallest Y value was $2, and our largest Y value was $10. So our Y values, our smallest value is 2. Y, the amount charged, is greater than or equal to $2. It's less than or equal to $10. So you want to make sure, well, first of all, you're going to have your credit card hooked up to the app anyway, so you're not giving cash. But if this was cash, you would need to make sure you have 2 $1 bills all the way up to a $10 bill, maybe some ones, maybe a 5, etc. It doesn't make as much sense using actual money because coins are involved. Let's move on. Here is the actual definition of domain and range. Domain, a set of all input values, X, which produce a set of valid output values, y, from a function. Domain is x. Domain is x. If any of you have ever listened to rap music from the late 90s to early 2000s, there was a rapper called DMX. I like DMX. And domain has a D and an M, and it has representing the X. Another way to remember that domain represents an X is the actual domain in Austin, Texas. The domain is over by my house on the north side of Austin, but the domain is so expensive. Get it? Domain is expensive. Yes, I know I spelled that wrong. Expensive. Okay. Domain is X. Now let's read what range represents. You guessed it. Range is a set of output values for Y. Range is our Y output values. Okay, so we have domain X, range Y. Let's take a look at it. In this graph, our domain is how wide the graph is. So I'm going to write the domain answer. So this is the graph that we're looking at right here. That is the graph I want you to look at. Domain is X. This is the X-axis. So our little squiggle, it shows that the domain starts on this -3 and it spans to this dot of 1 because this is the end and that's at X equals 1. This is the beginning, and that's at X equals, or X is at -3. So to write the domain, I would say X is greater than -3, because that's an open dot. Since this is a closed dot, I would say less than or equal to 1. That's my domain. It's the width of the graph. It starts at -3, it ends at +1, and that squiggle stays in between those two numbers. Now let's talk about range. Let's get out green. Range is the height, okay? Range is the height of the graph. So you want to think, how low can you go? And how high does it go? So the lowest, and you're going to look at the y-axis. So it's this one. The lowest point on this squiggle is right here. That's the lowest. And right here. Those tie for being the lowest. And those values line up with -4. Now, the tallest or the highest point on the graph is right here and right here. That is where it's the highest. All right. And that is at y of 0. So this is the highest y of 0, and this is the lowest y, -4. So my range is greater than or equal to -4. And the reason why I said equal is because of the solid dots. And it is, because of this point right here, less than or equal to 0. Now I know that this is an open dot, but this is a closed dot. So therefore my answer has to be equal to 0 because right there, that's 0, 0. Notice that the x, this x is in between -3 and 1. And notice this y is in between or equal -4 to 0. Let's take a look at this. Domain is the width, range is the height. Domain is the width, range is the height. So, oopsies, don't do that. Notice the domain starts off, the width starts off small, but as I move, I'm noticing my width is getting wider and wider and wider and wider. My width is getting wider the higher that I go. So that's why there's an arrow going in both directions in purple, because my width keeps growing wider. So what that means is the domain is all real numbers. Another way to write all real numbers is a fancy R. That is the symbol for all real numbers. Okay, and let's look at the range. Remember, range is the Y. It's from the lowest to the highest point. So I see that the lowest point is right there, and the Y value is -1. This point is 2, -1. So the Y is the range, -1. That's how low it goes. Now notice the Y values keep getting higher and higher, and then there's an arrow. And the Y values keep getting higher and higher, and there's an arrow. An arrow means it keeps going. It doesn't stop. So for my range, I'm going to have Y starts at -1 and it gets greater than or equal to -1. It's equal to -1 right here, and it's greater than -1 up there. It still may feel a little fuzzy. Let's keep going. How do we write the domain and range in continuous data? You will see the graph as one of 3 ways or a combination of them. So here is a graph. We've already looked at this, but it starts and it stops. So for X, it starts here and it stops here. It's our job to match what X it starts and stops on. But so because X starts at -3 and it stops at +1, we are going to write our inequality as a compound AND statement. If you look at how they have it here, they have it written like it's an AND. Here we go. X is greater than -3 and less than or equal to 1. For the Y value, we said that the lowest Y is at -4 and the highest Y is at 0. So Y is greater than or equal to -4 and less than or equal to 0. So we can see in this graph, when you have a start and a stop, it's almost like you can take the shape and put it in a box. You can take the shape kind of put it in a picture frame. You can put that shape in a picture frame. I need the X on the right and the left. I need the Y on the bottom and the top. Those 4 numbers make your domain and range. So that is a start and a stop and a start and a stop. Let's take a look at a function that has a start, but it never stops. All right, this is called start and no stop. So let's look at domain, which is my X. X, I want to look left and right because the X-axis goes from left to right. So looking at my left, I notice this function starts right here on -3. I notice on the right that it's connected to this arrow saying you are going this way and this way forever. Okay, so how do we write that as an inequality? Well, since domain means X and there is a start and no stop, you can write it like this. X is greater than -3. That's it. Any number that you pick greater than -3, you'll end up on the line. If you pick -3, you're going to end up right here. If you pick -1, you're going to end up right there. If you pick +4, you're going to end up right here. So as long as you pick x's greater than -3, you're going to land on the line. Okay, now let's talk about the range. The range is the height, the bottom and the top. Now, the bottom has an arrow saying there really isn't a bottom because the arrow says keep going down, keep going down, keep going down. That means there's not a bottom. It never stops. So there is no stop right there. Now let's look at the top. The top starts at 5. So the range, if you look at this number 5, notice that all of my values are below my 5. So all of my y's need to be less than 5. If you pick a value of 4 right here, you'll end up right there. If you pick a value of 2, you'll end up right there. If you pick a y value of -1, you'll end up right here on the line. If you pick a y value of -3, you will end up right there on the line. So a start and a no stop has one inequality sign. Write that down. Our answer has one inequality sign. X is greater than -3. Y is less than 5. A start and a stop has 2 inequality signs. And they always point left. I don't know if your teacher told you that, but they always point left. These are always the small numbers. And this would always be the big number. And it's true for both domain and range. This is my small number, -4, and this is my big number, 0. And it's like that for every problem. All right, let's see what a no start and no stop means. It means all real numbers and infinity. So let's take a look at it. All right, I'm going to go back to domain is X. X is the width from left and right. Notice that this arrow continues to go that way left. It's going down and it's going more left. This arrow is going up and it's going more right. So as we get bigger numbers, the graph gets higher. I go to this number, I'm now way up here. So I can't predict when it's going to stop, and it's not going to stop. And why I know that is because there's an arrow saying, please don't stop me. So your answer for the domain is simple. All real numbers. You can spell it out or write the symbol. For range, we're looking for the bottom and the top. Notice this arrow says go down forever, which means there's not a bottom, and it also goes up forever, so it means it's not a top. If there's not a bottom and a top, then it's all real numbers. You can write out the word or you can write the symbol, all real numbers. And these are just some little tips not to forget. If you see the open dot on the graph, make sure you're using these inequality signs. If you see a solid point or a connected curve or line, you're going to use your equal to's. And I did point this out a minute ago. A start and a stop means you can fit it in the box, in the picture frame. So it doesn't go past this hand and it doesn't go past this hand. That's for X. It doesn't go below my chin. It doesn't go above my head. That's Y. Start, stop, start, stop. Got it? Lastly, this is a start and no stop, which means there's one arrow. You're going to have one sign, or you could have the other symbol. And then no start and no stop means two arrows going in opposite directions. You can write X is greater than negative infinity, X is less than or equal to positive infinity. I don't want to write that. This is the fastest way to write all real numbers. Just write it with a double R. And I don't know how to type up a double R, so it looks like a regular R, but know that it's really a double R. Now that our notes are over now, what I want you to do is look at your first question on your homework, which is page 12. I went ahead and typed up the numbers on the graph that you're counting by one, and you may have already noticed that. What I want you to notice is that this function starts, but it doesn't stop. Does everybody see where it starts? Right there. It starts, and does everybody see how it doesn't stop? Because of the arrow. Don't stop. So this says, don't stop going to the right and don't stop going up, because there is a slight curve. So it'll continue to go to the right and it'll continue to go up forever. So because I made it A, B, C, or D for domain, domain is X. So X is left and right because it's your horizontal axis. The smallest X is -3, but it's not bubbled in. This would mean bubble me in, this means don't, and this means don't. So because it's an open circle, I know it's not going to be bubbled in. I know it can't be A. And because I'm looking at the X numbers start with -3. Now I can say the answer is B. For the range represents the Y. It is the height. So we're looking from the bottom to the top. And our lowest bottom is the starting point here, and its lowest number is 1. It is an open dot. Who's texting me this late? It is 11:36 p.m. Ha, I'm popular. Y is greater than 1 would be an open dot, and Y is greater than -3 would also be an open dot. So we can cross off choice D, because choice D, equal, means bubble me in, and that ain't bubbled in. We also want to cross off F because that's looking at the wrong number. So the correct answer happens to be E. All the Y values of this range are greater than 1. Notice if I draw a line through the 1 on the Y, notice all of this is above that, which means it's greater, it's above it. Let me look at one more example that I just randomly Googled. I Googled continuous data graphs, and this is what I get. So if I start annotating on the screen, now I'm going to pick the graph right here. When I write the domain and the range, I need to know the X and I need to know the Y. This is connected data. Connected is continuous. So it looks like this is a 5 and this is a 10, and there's one line in between each box, which means we're counting by ones. This looks like a start and a stop. We're starting right here on the X equals 1. We're stopping right here on X equals 12. So my domain is X is greater than or equal to -1. Oops, excuse me, +1. And X is less than or equal to 12. If you pick an X between +1 and 12, you are going to land somewhere on this little zigzag. It's a range of numbers. All right, let me erase all this riffraff. I'm going to leave the answer for the domain on the screen. Now let's do range in pink. Range is the bottom to the top. So it looks like the bottom of this zigzag is going to be down here at -20, and the highest point is going to be up there on 30. There is a starting number and a stopping number. So our Y is going to be greater than or equal to the bottom number, which is -20. And I put equal because that's a bubbled in dot. It's also the Y value will be less than or equal to 30 because that's a colored in dot as well. So as long as you stay between -20 and +30, you are going to land somewhere on the zigzag. All right. That concludes continuous data, domain, and range. Please feel free to continue on your homework. You have 9 problems left to do. All right, 11:39, I'm hitting sack. Have a good night. Bye.